Hello everybody, let's talk about solving compound inequalities. So I talked about how to graph basic compound inequalities in class. Now we're going to actually solve some compound inequalities. So we're going to solve the inequality and graph the solution. So this first one I have 3 is less than 3x minus 6, which is less than or equal to 18. In order to solve this, start by drawing some lines straight down from the inequalities. Now the goal again is to try and get x by itself. So if you look for x, it's in the middle. So I want to end up with a lone x in the middle, which means I got to get rid of this 3 and I got to get rid of the negative 6. As with any other solving problem, in order to get x by itself, you're going to work the order of operations backwards. So I want to get rid of addition subtraction first, which means I got to get rid of a minus 6. So what I'm going to do is I'm going to do plus 6 here. But here's the deal. In previous problems, we would do it on one side, you do it on the other. But with compound inequality problems, specifically this one, there's actually 3 sides to this problem, which is fine. You just do plus 6 in all 3 sides. And the same rules for solving inequalities remains the same, which means if you multiply or divide by a negative, you're going to flip the inequality, things like that. So on the left side, I have 3 plus 6, which is 9. Since I'm just adding, inequality stays the same. The center, minus 6 and plus 6 is 0, so I just get a 3x. And on the right side, I have 18 plus 6, which is 24. Only thing left to do is get that x by itself by getting rid of the 3. This is 3 times x. So I'm going to divide by 3 here, divide it on the left, divide it on the right. So I have 9 divided by 3, which is 3. Dividing by a positive 3, do not flip the inequality. 3 divided by 3 is 1, so I just get my x. And on the right side, I have 24 divided by 3, which is 8. And again, we already talked about graphing these in class, but what we're going to do is kind of same rules apply. So I have a 3 is less than x. So because of this symbol, I'm going to have an open circle at 3. And then I have x is less than or equal to 8. So at 8, we should have a closed circle. If you notice, x is in the middle. So what we're going to do is we're going to put our shading in the middle. We talked about why that works in class with the graphing of those. All right, let's do another example. So the next one, I have 13 is less than 5 minus 2x, which is less than 23. Again, the goal is to get x by itself. If we have to distribute, combine like terms, stuff like that, always take care of that first. And then order of operations backwards. So I have to get rid of the 5 and this minus 2 with the x. I'm going to get rid of this 5 first. This is actually an addition subtraction piece. So I'm going to subtract 5 because it's already a positive 5. Do it on all 3 sides. 13 minus 5 is 8. Since I'm subtracting, do not flip the inequality. 5 minus 5 is 0, so all that's left in the center is minus 2x. Do not flip the inequality. 23 minus 5 is 18. Only thing left to do is get rid of that negative 2 there, so I'm going to divide by negative 2, divide by negative 2, divide by negative 2. 8 divided by negative 2 is negative 4. Because I divided here in red, divided by negative 2, I'm going to flip the inequality. So instead of opening to the right, we're going to open to the left. The negative 2's, that divides to 1, so I just get an x in the middle. And on the right side, 18 divided by negative 2 is negative 9. We did talk about flipping the inequality. So I have negative 4 is greater than x, which is greater than negative 9. So when I get to the graphing, at negative 4, I should have an open circle. And at negative 9, I should have an open circle. And notice how x is in the middle. We talked about graphing that. So continue with the shading in the middle. What that means is all the numbers that are shaded in here are solutions to this problem, just like this one up above. All numbers that are shaded, so not the 3, but 4, 5, 6, 7, and 8 are all answers to that above problem. Negative 8, negative 7, negative 6, negative 5 are all answers to this problem. One more example I have for you on the back here. We're going to look at an OR for a compound inequality. So F3 is less than 3, parentheses x minus 3. or 4x plus 3 is less than or equal to negative 5. The way I'm going to do this is I kind of just do it one step at a time. Take care of one inequality, then I'm going to take care of the other. So look at this first one. I see parentheses there. So I'm going to distribute. So still have 3 over here. On the right side, I'm going to have a 3x minus 9. And then we need to solve that. There are no like terms combined there, so solving. So hopefully at this point, feeling pretty fresh. Should add 9 to both sides. 3 plus 9 is 12. Minus 9 and plus 9 is gone on the right side, so you just have 3x. Divide by 3, divide by 3. 12 divided by 3 is 4. Do not switch. Should just get an x on the right. And we could graph this, so 4 is less than x, so at 4 we should have an open circle. If we plug in 0 to test our shading here, we have 4 less than 0, which is false. If it was true, we go towards the 0, because I plugged in 0. If it's false, we're going to go away, so I'm going to go to the right. And on the same graph, I'm going to do this second one. So no distributing there, no combining like terms, so just work through PEMDAS backwards. Subtract 3, subtract 3. So that's going to give me a 4x is less than or equal to negative 5 minus 3 is negative 8. Got to get rid of the 4, so divide by 4, divide by 4. Get x is less than or equal to negative 2. So my solutions here are these two pieces right here. 4 is less than x, or x is less than or equal to negative 2. So I'm going to go to negative 2, close circle. I can plug in 0 to test. 0 is less than or equal to negative 2. That is false. So we go away from 0, which is to the left. And that was solving compound inequalities.